First is to find out R equivalent, which you have find out by, these are two parallel combination R2 and R3. So R23 is equal to R2 into R3 divided by R2 plus R3. So it's 7 multiplied by 2 divided by 9. So 14 upon 9, which is equal to how much?
1.56.
1.556 ohm. And this one is in series with that one. So if I draw that separately again, then it will be, this is R1, R23, which is equal to 1.56. And this one is R1, which is equal to 5 ohms. So now R1, 2, 3, because they are in series, so it will be 6.56. Am I right?
Yes.
So what about you?
Yes.
Good.
Yeah, I got it.
Now the second part is, once you find out this one, then you have to first step is to find out the series, total current of it, which is equal to I is equal to V upon R. So V is 5 and the resistance is 6.56. So what is it?
What did you say?
I just said total current. 5 upon 6. 0.76.
76.
Now that is a total current, right? Now we can shift back to the, in this circuit, we know that series circuit, the current will be same. So if the current will be same, then what will be the thing? We should know that I is equal to I1 equal to I23 equals to 0.76. So now
Yes.
ampere is known. So I think we better find out the power of one, which is equal to, in that case, I square R. So I
Yes.
is
So
0.76 square and R1 is 5. What is the value?
2.9.
2.89. 2.9.
2.9 or 2.89 watts, right?
Yes.
Yeah.
Now, because current is passing through that one as well, so let's find out V23. So V23 is equal to I23 into R23. So I23 is also 0.76 multiplied by 1.56. What is the value?
1.19.
Now we know that
Yeah.
your R23 is a parallel combination of R2 and R3, so voltage remain the same. So we can say that V23 is equal to V2 is equal to V3 equal to 1.19 volts. I think we
Okay.
have found one of the unknown. I don't know which one. Let's see. We found out I3. We I think found out. Let's find out I2 then. So I2 is equal to V2 upon.
5/7.
So V2 is 1.19 over R2, which is 7. So what is the value?
It is 0.17.
That's it.
Yeah.
Noted. Okay. Understood?
Yeah.
Now I want you to try one question. It will be a parallel circuit once again, but there is a small difference. You will find it yourself. So in these questions, you may ask you different type of questions. One very small thing which we left with, we will do it right in a few minutes. Okay. Now the next one is, okay. This is 5 ohms, 6 ohms, 10 ohms. Voltage I increases to 10 volts. Now what is I3? what is V2, and what is P1, and definitely R effective. How to do this?
You're asking like I just say now how to do this?
Yeah, please.
I think first you make the series R2 and R3 as one resistor, so the series circuit first.
Yeah, that's what you have to do. This is the reverse of the previous one. These are the three type of things which are in our course.
So it's basically 16 ohms.
And that 16 ohms will be in parallel with the R1 resistor.
Then you use the R effective formula. So 16 times 5 over 16 plus 5.
Yep.
That should be 3.81.
You mean the R effective one, right?
Yes. So
What about you, Alicia?
I'm sorry, can you repeat what you said? Hello?
Yeah, I'm listening. So it is R23, which is equal to 6
Hello?
plus, yeah, hello. Can you hear me?
Oh, sorry.
Yes, hello.
Hello?
Yes, hello.
Oh, yeah, can you repeat what you said?
Yeah, I'm there. So 16 ohms, right? This one is in parallel with the resistance. So R1 is 5 ohms, and this one is 16 ohms. Now R123 will be
16 times 5 divided by 16 plus 5, is it?
yes. So basically, it will be 5 into 16 divided by 21. So what is the value coming up?
I got 3.81.
3.81. Is it 3.81, Alicia?
Let me check. Yeah, it's 3 point, yeah, it's 3.8.
And then, don't say it. Now the next is very interesting. I mean, you already found out the equivalent thing. Now, how to proceed with this? All right. Now you have the circuit. This is 10 volt. Now find the I total. What is it?
2.62.
Okay. This is the resist. I mean, ampere. So this is the current. Now, because two resistances are in parallel, so the voltage remains the same. It means 10 volt for V1. Okay. So this is the voltage. So now I1, R1. It will be I1. Okay. Now we know that voltage across this voltage is same and they are in series. So let's find out I23. Ten upon 16, how much?
Um,
0.625.
yeah.
So now the current is passing through, so it means current will be same. So now what are they asking for? P1, and the P1 is what is this value?
20,
20.
How much?
20.
20.
20. Okay, now this one is non. Now what else they are asking for?
Um,
This one,
6.
6.
That's 3.75.
That's it. Understood?
Yes.
Yeah.
Okay, try this question I'm writing, and then we will proceed to waves. Okay. I want you to find me I3, I2, and V3 and P1. Okay, try this. I give you 5 minutes to solve it. After 5 minutes, I'll
Okay.
see you. Okay. This is your R123, the resultant, or you can say the total R equivalent. Now V23 is that, and R23 is 9, right? 9 ohms. So you can, by the way, they are asking you for I2 and I3. So now you tell me this is series, right? So basically in series circuit, if you find out by any chance I23, which is equal to V23 over R23. So V23 is 5 and 9. What is the value?
What?
V23 upon R23.
That's 0.56.
0.56, right? Now this current is actually the current through I2 and I3 because they are in series. So I2 is equal to I3 is equal to 0.56. So technically speaking, you have solved the question. Now V3 will be equal to I3 R3. 0.56 multiplied by 7.
Um, 3.89.
How much?
3.89.
89. Okay. Volts.
Okay, I understand.
So this is done. Now, shall we move on? Because this one is the one we have done already. Now, one small formula which actually I wanted to show you is your resistance depending on some factors. We have talked about this in the previous lectures. One is the temperature. What is the other one?
Um,
Is
length,
it length and area?
area,
Length of a conductor
and area of a conductor.
and area of the cross section of the conductor. This is directly proportional. We can say L, and that is inversely proportional, which is the area. If you combine these two, you can say R directly proportional to L upon A. And when you remove this directly proportional term, you come across with this thing. This is called rho L over A. So this is called rho, and this is also called as resistivity. And what exactly is resistivity? How to explain that? So resistivity is equal to R A upon L. Let's find out what exactly it is. Resistance is ohms, area is meter square, length is meter. So the answer or the unit will be ohm meter. So this is ohmage or ohms for the specific resistance. 1 meter of a resistance.
Okay.
Okay. So this is a small formula we had it. Understood? Any questions?
Yeah.
No.
So shall we proceed further with the next topic?
Yes.
Now the next topic is waves. Electricity is sorted, done, everything done. Any questions you can ask later on. Let's start with waves. What is waves, Pan? How do we explain that?
Wave is an electromagnetic wave or a mechanical wave.
Now the thing you are telling me is very complicated because if a person who didn't know anything about wave, how do you explain what exactly is a wave?
It's the movement of energy.
Okay. So basically, it's the way of transfer energy from one point to another inside the medium. Am I right?
Right.
Yeah.
Now we can understand that. But what exactly is wave? How to explain that? Let's see that. Let's consider a trough of water here. This is your trough of water. And because this is a water, so I give it a name. It's a medium. Medium means a general medium. Here we took it as water. Okay. Now the medium is very smooth. When I say smooth, what does it mean?
Um,
No ripples.
There-
Like,
No ripples.
yeah.
Or in other words, no disturbance.
yeah.
If I draw a graph for this against the time, so because there is no ripple, so you will have a straight line like this. We call this straight line as equilibrium condition or position, whatever you want, or rest position, or mean position. This is the position when there is no ripple or no disturbance. Am I right?
Right.
Yeah.
Now, point is, when you throw a stone into this, what happened?
And ripples.
Ripples. And ripple means you are actually transferring energy through the stone. Stone hits the particle of the water. Then one particle strike the other particle strike the other particle. So that's a transfer of energy in such a way. So technically speaking, particles are not moving properly, but the energy transfer by striking one particle to another particle. Am I right?
Yeah.
So we can
Yeah.
say a wave is a disturbance produced in a medium. It's a disturbance that is produced in a medium. You disturb the medium of the water and waves are produced inside the water. Okay. So wave are the basically ripples which you were talking about. And they are the disturbance which is produced in a medium. Now, once we establish that these are the disturbance which is produced in a medium, one more thing we need to establish here is how many types of wave we have. Okay,
Mechanical and progressive.
not progressive. Progressive is some other. We will come to progressive wave.
Electromagnetic.
Yeah, for the time being, just progressive means all the waves which are traveling. That's what they called as progressive. So when you say progressive, it means they are going and going. And when you say the standard, I mean, standing wave, they are not going further. They reflect back. That's the reason we call them. Okay. So let's see what are the two types. On the basis of passing through the medium, on the basis of passing through the medium, there are two types of wave. One is called as a mechanical wave. And the second one is called as electromagnetic wave. Now, what is mechanical wave?
Sound waves.
Uh-huh.
Basically, a wave that needs a medium to
Yes,
travel in.
absolutely. A wave or a disturbance which needs medium to travel. Example is sound waves, water waves, what you just said. The second one is electromagnetic wave, which do not need medium to travel. Now, what are these waves? Example,
Light.
light waves. We will see this in a bit detail once we finish with the mechanical waves. A small, quick, the details of this electromagnetic spectrum and uses of these waves. Because light is different kind. Light has a different kind, like because some light you can see, some light you cannot. Now, first mechanical wave. Now, mechanical wave or electromagnetic wave on the basis of shape. There are two types of wave. One is called transfer waves. Second is longitudinal wave. Longitudinal wave and transfer wave. Transfer waves. Let's talk about this. This is your transfer waves. How do you explain it?
Particles vibrate parallel to the direction of propagation.
Let's see. But you're wrong actually. From left to right, if you see the propagation of the wave, right? How do particles are moving? Up and down?
Yes.
So can I
Perpendicular, sorry.
perpendicular, right? So we can say in this wave, particle of the medium travel perpendicular to the direction
Of energy
to
transfer.
direction of the propagation
Energy transfer.
of wave.
Can I just say energy transfer?
No, you better use the word propagation of wave because you can say that that's not an issue, but because we are studying waves, so better use the word wave, you know. If you even use the energy word, you better use the wave
No.
along with that as well.
You said to the direction of propagation of wave. I'm just saying, otherwise, can't I just say direction to the of the energy transfer?
But energy will be transferred in different form as well, like you know, thermal energy, heat energy. When it transfers, it's just an energy transfer. So you need to mention that you are talking about wave.
Okay.
Because in chapter of waves in IGCSEs, you may find out that heat is also transferred in the form of energy. So how do you differentiate that? So you better use the word wave because we are studying wave, right?
Okay.
Now, important word. This is how they are perpendicular to each other. Now, there are terms related to that which we should know, right? I'll write them one by one and you will see that. First is called rest position. Position or equilibrium position. Now, what is this position? How to explain that?
Rest position.
Mean position or equilibrium position?
When it's at 0.
You can say this is the position of medium when no wave is produced in the medium. So at this point, no wave is there. So that position is called as mean position of the medium. First word is called as, that word is displacement. Now, what is displacement?
Displacement is the amplitude.
Amplitude is different. You know, if I talk about this particle, let's suppose its vertical distance from the mean position is called as displacement. If I'm talking about this particle, then its distance from the mean position is called as displacement. So you can say vertical distance of the particle of the medium from rest position or main position. And what is the SI unit for this?
Meter?
Meters. SI unit of displacement is meters. Second thing is amplitude, which you were talking about. So what is it?
The height of the wave.
It's the same thing. Maximum displacement is called as maximum displacement from the mean position is called. Now, for example, here the maximum point is this. So this distance is called amplitude. So it means that all the distance, all the displacements are not amplitude, but all the amplitude are first displacement. Okay? The unit is same,
Okay.
meters. Now the third thing is called time period. Time required to pass one complete wave. And what is the unit for this? Seconds. Now there are two more things which are crusts and trough. What are these?
Wait, can I say one thing quickly?
Yes, please.
Can you explain to me again what did you mean by equilibrium? I cannot understand what you've written.
It's equilibrium position, this one. This position is called as equilibrium position. This one, straight line. And that is a position where no wave is produced. When there was a smooth medium, that position is called as equilibrium position. What I wrote is,
Okay.
this is the position of a medium when no wave is produced in the medium. Okay?
Okay.
Now the upper part from the mean position is called as crest, and the lower part from the mean position is called as trough. So you can say that upper part of the wave from the mean position and trough is the lower part of the wave from the equilibrium position or mean position. Understood?
Okay.
Next word is called frequency. What is it?
Frequency. It is the number of waves per second.
Yes, number of waves passing. Number of wave passing through a point in 1 second. F is equal to number of waves per unit time. What is the unit for this?
Hertz.
Its actual unit is 1 upon seconds, or you can say second inverse. But the scientist who discovered it, he gave second inverse a name called hertz. So we called
which
SI
is the
unit.
unit?
Okay.
Okay.
Now the last term left here is wavelength. What is the wavelength?
The length of the wave. One wave.
Now, what is the wavelength? Now, this is interesting. If you check this crust here, and if you check this crust here, the distance between two crusts is called as wave length. And we represent it by this sign, and we called this sign as lambda. So distance between two consecutive crusts or difference between two consecutive crusts. Like for example, you have a wave. Now this is your crust and this is your crust. So that distance is called as wavelength. And if this is your trough and this is your trough, that distance is called as lambda. So we can say that distance between two consecutive crusts or two consecutive troughs. That is what we called as wavelength. The sign we represent the wavelength is called as this lambda. And the unit is again meters. Okay, understand?
Yes.
Yeah.
Okay, I think we stop it here. We have done transfer waves. Now, same thing, we will do it in a transfer waves and then we will proceed further. Then I will explain it to you what is your superposition. And then we will come to interference and some progressive wave and standing wave, and that's it. And then, inshallah, from Monday, hopefully, you will be joining Manur, right?
Yeah.
Yeah.
Yep.
Okay.
Then take care. Bye.
Wait, so what topics will we join Manur? What topic will we join Manur with?
I think so. We will be there with on that might be photoelectric effect and that
Oh, okay.
activity which you were talking about, radioactivity and all this.
Oh, that's
Really?
paper one. So we'll do paper one then.
Yeah, because at the
Okay.
moment we are talking about waves and that thing. Because you in your course, this part, the radioactive part, is also a part of the wave.
Oh, okay.
Because
Really?
some radioactivity, alpha, beta, gamma rays, and these all are also.
Oh,
a
yeah. Okay.
So hopefully, might be when you join her, we are maybe at that photoelectric effect. If not photoelectric effect, then minimum it will be
Yeah.
radioactivity. And in hopefully once
Okay.
whatever topic we left with, we will cover up in the last, because is after that I will jump onto that mechanics and the materials paper.
Yeah. Okay.
And once we finish with that, we will see
Okay.
if anything left with this, and we will revise that. And we are also doing the past paper as well. Okay.
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 Okay. See you tomorrow then. Bye.